Okay, so to justify this recursive definition, I'm going to use an example. So we'll use this sentence we've seen before. And let's see how we can calculate the value for pi 7 PD. So recall, this is going to be the highest probability for any tag sequence ending in tags P and D at positions 6 and 7. So first let's see how this expression works out when we instantiate it for this particular pi value. So I have a max over W in, now K is 7, so we're looking at S5. This is simply the set of possible tags at position 5, and that is equal to the set of tags S, which is equal to D and VP. So we have a max over those 4 possible tags. And then I have pi of 6 WP, and then I have Q of D given WP, and then finally I have E of XK. K is 7 in this case, so this is the 7th word in the sentence there, given D. So this is the expression which we can use to calculate pi 7 PD. So how can we justify this? The key insight is that if we think of any tag sequence ending in P and D at positions 6 and 7, it has to have included some tag at position 5. And this max is explicitly searching over these different possible values for this tag at position 5. For each possible value of the tag, we multiply in the pi value, and then a Q value of D given the previous 2 tags, and finally an emission value of the given D. The reason we do that is if we fix a particular tag, say N, at position 5, then the following property holds. The highest probability path going through tags NPD at positions 5, 6, and 7 has to have probability pi 6 NP times Q of D given NP times E of there given D. So that's the highest score for any tag sequence ending in NPD at positions 5, 6, 7. Why is that? Well, the highest scoring tag sequence ending in NPD at positions 5, 6, 7 has to include the highest scoring tag sequence ending in positions N and P at positions 5 and 6. That's what this probability is. And then we multiply in the trigram parameter Q and the emission parameter E to take into account the probability for this tag and this emission probability. So that's the highest probability for any tag sequence going through NPD, and we simply do a search over all possible tags at this previous position and take the max. And that gives us the highest probability tag sequence ending in P and D, position 6 and 7